Hi everyone, I'm Dr. Syed Mustafa Safavi, a cybersecurity researcher and academic with a focus on AI, system architecture, and digital security. I'm joined by Sarah Johnson, a tech entrepreneur and strategist working across emerging technologies. In this podcast series, we combine academic insight and real-world practice to explore critical topics in tech and innovation. Whether you're a student, professional, or enthusiast, you'll gain a balanced perspective grounded in both theory and application. Make sure to subscribe, follow, and join us on this journey as we unpack the future of technology, one episode at a time.
Welcome, everyone. Let's dive into operating systems, exploring how they've shaped computing over the years and their role as the backbone of our devices.
Absolutely. It's fascinating how these systems go from being mere interfaces to complex managers for processes, memory, and even security, right?
Exactly. And at the core, an operating system is this neat piece of software that acts like an interface between the user and the hardware, handling everything from process scheduling to device management.
Yeah, right? It's like the silent coordinator that makes sure everything from the CPU to the memory is working in harmony.
Absolutely. It's like, this master conductor in an orchestra telling each instrument exactly when to play, albeit in a very technological sort of way.
That's a cool analogy. So what about the evolution? How did we get here from those early days?
Well, the journey is really interesting. It all started in the 1940s and 50s with vacuum tubes and plug boards. Back then, computers had no operating systems, and a single user controlled the entire machine.
So each user actually had their exclusive time on the machine, correct?
Exactly. Then, in the late 50s and 60s, the introduction of transistors brought about batch systems. Users would submit jobs, and these jobs were processed in batches. It was like lining up orders at a busy diner.
That sounds like a very ordered yet somewhat rigid approach, limiting interactivity, no?
Right, and that's where things evolved further. The integration of microprocessors in the 70s spawned personal computers and systems like Unix and MS-DOS. And now we're in an era where modern operating systems run everything from desktops to mobile devices.
It's wild how much progress there's been. With systems now handling multitasking, time-sharing, multi-programming, and even real-time tasks. Can you walk me through some of these classifications?
Sure, let's get into that. For instance, multitasking systems allow for multiple programs to execute concurrently, giving each process a slice of processor time. It's like juggling several balls at once.
Right, and what about time-sharing systems?
Time-sharing systems, on the other hand, let multiple users interact with the computer simultaneously. They share resources like CPU and memory in rapid alternation, sort of like a hot potato game with data.
Yeah, and then there are real-time operating systems designed for systems where responses must be immediate, like in medical devices or robotics. That really ups the stakes, doesn't it?
Exactly. Real-time systems need to be deterministic, meaning they respond within a specific time frame. Think of it like an airbag deploying in a car crash. Timing is everything.
I see, but how do these systems actually manage all that? What key services do they provide?
Well, operating systems handle a host of critical services. They manage program execution, loading, running, and eventually terminating programs. They also control input-output operations, file system manipulation, basically enabling applications to create, read, update, and delete files. Plus, they manage device communication using drivers.
I get that. And memory management is also a huge deal, like keeping track of what's in RAM, ensuring the right parts are available to applications, and even swapping when needed.
Yes, indeed, memory management is crucial because it prevents conflicts and makes the system more efficient overall. It's like having a highly organized closet for all your data.
Yeah, and security plays a part too, doesn't it? Keeping unauthorized users and malware away from sensitive processes.
Absolutely. Security and access control ensure that resources and data are protected. In modern operating systems, there's a big emphasis on robust access control mechanisms and monitoring.
Right? It's impressive how these systems have integrated so many functions, from process management to providing user interfaces, be they command line or graphical. Although, don't you think sometimes these layers add unnecessary complexity to simpler systems?
That's a fair critique. Sometimes, especially in embedded systems, the complexity can be trimmed down. But that's the beauty of specialized operating systems like embedded Linux or QNX. They're compact and efficient, tailored to specific hardware without all the extra bells and whistles.
That makes sense. It's like having a Swiss Army knife versus just a simple tool that does one thing well.
Exactly. And speaking of specialized systems, real-time OS and embedded OS are a perfect example. They're designed for precise operations in fields like industrial automation or automotive systems, where delays simply can't be tolerated.
Yeah, so much emphasis on determinism and reliability in those setups, huh?
Yeah, indeed. And then there's the historical aspect. As hardware advanced from vacuum tubes to microprocessors, operating systems evolved in tandem. Milestones-wise, each generation switched up the language and structure, from assembly, Fortran, COBOL, to now, languages like C, C++, Java, and even Python in some cases.
Right? It's kind of like watching the evolution of language in human history, from simple scripts to complex literature, each generation refining communication.
Exactly. That's a nice metaphor. And let's not forget about the layered architecture of computer systems. The OS acts as the intermediary between the high-level applications and the bare metal hardware, ensuring reliable execution and resource sharing.
That layered approach is really pivotal because it abstracts hardware complexity, allowing developers to focus on application logic rather than getting bogged down by low-level details.
Right. The OS works hard to shield programmers from those low-level intricacies, giving them a cleaner development environment. It's like providing a smooth, well-paved road for software to travel on.
And it's clear that understanding these core functions isn't just academic. It's essential for software development, system administration, and driving innovation in computing.
Absolutely. And the lecture really nails that point by highlighting topics like process management, memory, file systems, device communication, and the overall management of computer resources.
Yeah. Before we wrap up, I'm curious, how do you see future trends affecting operating systems?
Great question. As we look ahead, there's increased focus on security, deeper AI integration, cloud computing, and IoT support, which means operating systems will have to become even more agile and secure. They're continuously evolving to incorporate new technologies and address emerging needs.
I guess that means the next lecture, like on memory management, will tie into these trends by showing how efficient resource allocation becomes even more critical as systems become more interconnected.
Exactly. And it's exciting because these developments promise to make our interactions with technology more seamless and responsive, much like having a vigilant digital assistant always optimizing performance behind the scenes.
All in all, it seems that operating systems are not just the unsung heroes of computing. They're the very foundation that supports everything else, from everyday applications to advanced industrial systems.
Absolutely, and understanding them is crucial for anyone diving into computing. It's an endlessly fascinating area of study that shows just how intertwined software and hardware really are.
Right, indeed. This has been a truly engaging conversation. I'm already looking forward to seeing how these concepts evolve further and impact the future of tech.
Thanks for joining in on this deep dive. Stay tuned for more discussions on topics like memory management next week. And until then, keep exploring the wonderful world of operating systems.